here with me, one Michael Ford from Aegis and Harald Eppinger from Co-Young. Welcome to the panel. We've got about 15 minutes, so this is going to be like a super fast panel discussion about it. Let's go straight into it. So when we walk around shows like this, we see words like Industry 4.0, and that's obviously all about connected machine-to-machine communication, et cetera, and we're at a point where, like we discussed in the previous panel, the dream has become reality. What we often talk about is that machine-to-machine connectivity, but not always the entire supply chain of a production, from design right through to the end product and even beyond the recycling part, so to speak. So I'd like to touch on some of those areas with you as to how that has maybe changed the way you're working with your customers, what they are demanding from you. So actually, if I can start with Harald from a machine point of view, has that had any impact, and how are you dealing with the wide supply chain issues?
I think it's quite interesting changes happening over the last 2 years. In the previous aspects, we focused on the production shop floor and the problems directly, plus minus 2-3 meters from the potential root cause. With the connectivity of machines, with the exchange of data, and especially valuable data, it becomes a different aspect. You can look beyond your borders. Suddenly, a dimension of a component which is recognized in the production floor can be recorded to the purchase department that something goes wrong. In between, we have the connectivity to the MS systems. And I think this understanding, the link of these aspects of the findings, is the starting point of the supply chain understanding. Doesn't matter if it's your small one or the big one.
Because Industry 4.0 often is seen as something that is sort of within a boundary of a factory or multiple factories within an industry, but it really is beyond that. And from a MES systems solutions provider perspective, obviously you are looking at that entire environment.
Yeah, but I think for most customers, what you just said is the symptom of the problem, because you come along and every PCB has a different set of components on it. And you're thinking, why? What happened, you know? And the reason is very, very simple. The industry is going toward small lot sizes, high mix. We're going toward the Industry 4.0, where we're supposed to be able to change what we build on a daily basis. And all of the talk we have about connected machines and all of that stuff helps the factory achieve that. But the poor guys in the supply chain, what are they supposed to do? They're being told to reduce the stocks of material because they're expensive, and we know that that's the key money maker or breaker for manufacturing. And yet they're supposed to conjure materials out of thin air at the same time as hearing about shortages in the market, at the same time about hearing counterfeit. 15% of US military supply chain is suspected of being counterfeit. What does that mean for the rest of us? So we've got all of these pressures going on to the guys in purchasing. Mm-hmm. And this is why they value the feedback from these machines. Mm-hmm. So what we've looked at is how do we link Industry 4.0 through purchasing back to the material vendors. So it's this thing we call supply chain 4.0. It's not very original, I understand that, but it gives people the sense that this is designed to make the material procurement as responsive as manufacturing has to be. Mm-hmm. And so go onto the websites, go and research what components are genuine, good quality, good value, and are available to me now to satisfy this customer demand. And as an MES system, let these guys know what's coming so that he is not surprised, because that machine has a great amount of value in being able to detect changes and alterations. The people who designed that circuit board, they want to know your data, because they want to know, did that decision to change the material have effect on the product reliability in the market or the costs of production? So you put everything together, and this is gold, like gold information coming from machines, integrated with Industry 4.0, supply chain 4.0, and that drives then this future trend.
I think we can add here something. If you find an alternate component You have no experience on this. The moment you produce this component on your board and you get immediately the records of the dimension of the solder joints, the quality of the process you use within this component, you can reduce the time for the proof. So somebody has to decide to go for a new component. Can he do the trials? Can he really spend the time to figure out if this component is worth to go? So if not, because of the pressure, we need to get quickly the feedback of all dimensions. And the combination of communication, on one hand the machine to machine, that's one part, but also from the machines into the upper layers and to the outside world of SMT, this is the most important thing. Communication style has changed significantly. We have never been talking about machine manufacturers so often about data exchange and what kind of data we can generate to utilize the benefit for the operators, for the customer. And I think this is important. The knowledge is there, the gold is there, but how to utilize it, that's the big thing to do it.
And I guess that it raises a lot of questions that I come across a lot because, as you say, it is gold information, but for some it's also information they don't necessarily want to share. So there's in certain industries, and you touched on military, I'm sure in automotive it'll be, medical certainly, the same where there's maybe a reluctance to give away that sort of information, or actually are we at a point where we have defined that space and are able to provide the information that's key to the benefits that we want to get out of it?
The perception of ownership and value of information has kind of changed a little bit because we now realize that the PCB layout, you need to understand that in manufacturing in order to run the machines. I mean, you need to know everything about that circuit board in order to provide the best possible analysis. People now realize that is true. And when we come to the material side, I mean, imagine the case where the board arrives in the machine here, and you are immediately able to show this component is different. Now, is that difference because of a conscious decision made in the supply chain, or have I detected a component that's counterfeit? We've seen cases where reels of components have every 7th component is counterfeit, and it's specifically designed to defeat incoming inspection, so that you just see a random pattern of failures, maybe in the market, maybe in production, and these guys are walking away with money at our expense. But they could be products that go into driverless cars, into aeroplanes, which fail, and people don't understand why. That's the world we're beginning to live in, except this guy has a solution. Because you recognize that component is bad. Somebody will come along and check within MES and the supply chain. No, we did not understand that there is a difference here. Let's have a look at that component. Oh, that looks wrong. Quarantine, everything. And so we've built in an automated feedback loop to prevent this kind of counterfeit issue going in. And that's just one of the benefits that this kind of data from the machine provides.
I think there's a good example. There is a change in the component, yeah? You see it, you feel it. And very often there was a discussion from the production guys why it's changed. First of all, we can prove that it's allowed. Secondly, these guys operating a machine, they had discussion with the purchase department. Did you change the dimension? Was the component cheaper? Sometimes an operator on the line could really prove that this component change has a quality impact. But he could not prove it to the purchase department. Now, with the tools of visualization and protocoling, it's really a solid decision. Take care of this supply chain, where this component came from. Is the vendor trustful? Can you rely on? Because it's a direct impact on the quality. Before it was impossible. You have a random defect on the board. What do you decide? Take care of it? Sending an email to whom? Now you press the button, you get the statistic, this component is, every 7th component is out of range. And we can prove this. And I think these weapons and decision guidelines, this is also new, that if you come back, nobody can question mark your findings. And this is the solid of the decision process.
So it's really giving you data to ensure quality, traceability, Does it go even beyond that and enable you to be able to plan your whole build, I suppose, in terms of cost, in order to define the best quality product to use and to pre-plan, not just to identify something that shouldn't be there or has changed, but actually to optimize your whole process by looking at the entire supply chain?
There is a great benefit for having consistency in supply chain, being able to know what component shapes are compatible with others and colors, so that we don't have to make so many changes in production. Change is the enemy of production. Okay, we're seeing a lot of high mix, so we're not really seeing a contiguous picture from one thing to the next. The information that's coming back now in digital format, it's being used by the supply chain people to choose and select the right components with design authority. Because the one thing we've not mentioned yet, the poor designer who designed that product, which is now failing in the market, which he is being questioned about, why did you make a product so unreliable? Well, actually it was production's fault because they used the wrong materials. Really? And this provides the critical feedback path, direct from the machine that has all of the knowledge, back to the designer who looked at the intent, and he is able to say, right, in future you do not use that combination of materials. Then you have a totally closed loop on the supply chain.
Especially for new designs, it becomes quite interesting. When you record all the data about your process, solder joint height, volume, offset, everything, you can predict even when you use this component in another layout, how you can execute it. So this kind of knowledge, put it into the supply chain thinking, is predicting a much higher output, much more safer product. I think that's the combination. You have different aspects to bring in the knowledge and also to take experience, historical experience, and put it forward into your production, into the ramp-up of the product. And I think that is the goal, of course.
One of the things, because we're also coming to the end of the discussion, I do want to touch on, particularly because it's very relevant in today's discussion when we turn on the news about the environmental impact of everything around us. And recycling of our products is a key aspect of that. And electronics does produce a lot of waste. One of the subjects that a lot of people have shown interest in over the past years is the circular economy, where we're recycling, rebringing products back into the system and not just throwing them away. When we look at everything we've discussed about the supply chain, do you feel that taking that control of the supply chain will enable providers that maybe aren't on that environmental level yet to be able to fulfill a long-term sustainable solution that is essentially saving the world?
That's a tall order.
Yeah.
Actually, with IPC, I work with the traceability standard, 1782. And within that standard, it's completely hierarchical. So you can track from the original kind of mining of key materials or conversion of sand into silicon all the way through to a final assembled product. So you can read the serial number of that finally assembled product in the market at the end of its life and say, I need to know exactly what the opportunity is here to take out those materials for recycling. Now, that has been possible for a long, long time by human intervention, which is very expensive, and that's not going to happen. Now it's available digitally because we are able to understand exactly what materials were used in every single instance of that product being made. And so for no cost, once you have a digital MES in there that's linked and providing all the values that we've talked about already, one value for free is that traceability. And so you're able then to provide that information into the public domain so that they understand the recyclable opportunity in every case.
So from our point of view, I think we have to focus short term on the waste we produce in a production environment. When we go straight to the goal, we have less waste, we all know. And I think from our aspect, this is our short-term vision. This is a long-term vision. We have to make sure that what you produce stays for the time and delivers the quality for the lifetime of the product, whatever this lifetime is predicted. But to keep this lifetime, we need the records. If
Yeah.
we know this is designed for 5 years, it's 5 years. But why you throw it away after 5 years when it can run 7 years? In the conservative market of industrial electronics, this is still okay. Boards are running for 20 years. If you go to the mobile industry, all the fancy stuff, it's overaged after 3 months. But it's a design issue, it's not a quality issue. So you have to throw away the mobile phone because it's not state of the art anymore. So this is something we have to learn. That's not a technical aspect, it's a mindset aspect. I can say if we reduce during the production process the waste, that's a direct impact. If we have more stable processes, it's all over less waste. And long term, we can guarantee the stability of a product much longer than the expected life cycle. And so everybody can contribute to save our environment.
Okay. Gentlemen, I'm sorry to interrupt, but we've come to the end of our session. Thank you very much for listening. I think Michael and Harald will be around for some questions straight away if you've got any questions to ask them. Thank you once again, and do watch out for What's in Electronics TV on YouTube, where you can rewatch these panel discussions as well as lots of other interviews as well.
Thank you.
Thank you very much.
Thank you.